Welcome to Review Recording 1A-B-C to accompany instructional recordings 1A, 1B, 1C for Section 4.4, Unit 4, Chapter 4, Mathematics 2200. We'll be working with the discriminant and using the quadratic formula to solve quadratic equations. Recall the quadratic formula. Given a quadratic equation in the form ax squared plus bx plus c equals 0, the solutions to that equation are x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And don't forget that the part underneath that root sign, that is called the discriminant. It can be used to tell us how many roots we have and whether those roots are real or non-real. Example 1. What are all the possible values of b in 2x squared plus bx plus 1 equals 0 if the equation has exactly one real root? First, we review the cases of the discriminant. If the discriminant is negative, we'll have non-real roots. If it's equal to 0, we have one real root or two equal real. If it's positive, then we have two unequal real roots. So it looks like we have to work with this case right here. So we've got to calculate the value of b squared minus 4ac. Our a value is 2. The b value, of course, we're kind of stuck with that. It's just b right now. And the c value is 1. And we want that to equal 0. So we basically got b squared minus 4 times 2 times 1 equals 0. That's b squared minus 8 equals 0. It's kind of like a quadratic equation here now. We've got b squared equals 8. We can solve this using the square root property because there's no middle term in our quadratic here. So we've got b equals plus or minus the square root of 8. Now that doesn't quite look like anything we have here, until we realize root of 8 can be expressed as the square root of 4 times the square root of 2. So we've really got plus or minus 2 root 2. The answer is B. The next one asks us to algebraically determine the exact roots in simplest form for this equation. Right away, I'll caution you against thinking that we can just make each factor equal to 0. We can only apply the zero product principle that we use when we factor if we're equal to 0 here. So we can't apply the principle because we're not equal to 0 here. We're going to have to do something else. Let's distribute that 2x into those two terms. So we've got 6x squared minus 2x equals 5. Now we can't even factor or apply the quadratic formula or anything else until we get this in the form ax squared plus bx plus c equals 0. So I'll even write in that step here right now. So we've got 6x squared minus 2x minus 5 equals 0. I'll bring the 5 over. Factoring, let's see. I don't think that one will factor. We can try till we're blue in the face. So I think we're going to have to use our quadratic formula. We've got x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. A helpful way to remember that is to sing it. X equals negative b plus or minus square root b squared minus 4ac all over 2a. I'm not known for my singing prowess, folks, so if I had to graduate high school based on my singing ability, I'd still be there. Now, identifying our values of a, b, and c, we've got a equals 6, b equals negative 2, c equals negative 5. So we plug those into our formula. X equals negative of b, so it's the negative of negative 2, plus or minus the square root of negative 2 squared. Make sure you use brackets there because you're squaring the whole thing. Now, minus 4 times a is 6, and c is -5. And we're all over 2 times our a value, 2 times 6. We've got x equals negative of -2 is 2 plus or minus square root of 4. Now here's the key place where you can make a mistake. We've got to subtract here, but we've got another negative here, so we're going to end up adding the result of this multiplication. 24 times 5. 4 times 6, 24 times 5, 120. All over 12. So we've got x equals 2 plus or minus the square root of 124 all over 12. More simplification can be done. Square root of 124, we can think of that as square root of 4 times the square root of 31 all over 12. And it looks like I'll have to go to a new slide. Now I brought my last step over to this slide. We've got x equals 2 plus or minus square root of 4 is 2, so we've got 2 root 31 all over 12. We can divide 2 into each of these terms. 2 goes into 2 once, and once there, and into 12 6 times. So our final answer is x equals 1 plus or minus root 31 all over 6. This slide reminds you of the discriminant is b squared minus 4ac, the 3 cases that we reviewed earlier for the discriminant. And when you're using the quadratic formula, make sure the equation you're working with is in this form.